The James Webb Space Telescope has unveiled something truly astonishing. Beams of light appearing to radiate from what looks like a distant, bustling metropolis located light years away. This extraordinary observation has reignited our curiosity about the possibility of extraterrestrial life. When the telescope focused its gaze on Proxima Centauri b, the closest known exoplanet to our solar system, it detected mysterious, dazzling flashes of light. Could these signals be the work of an advanced alien civilization? This discovery has set off waves of excitement. For centuries, the idea of life beyond Earth has captivated both scientists and the public alike. Even the faintest hint of alien life has stirred widespread speculation, but now we may be witnessing a historic breakthrough. The James Webb Space Telescope has delivered compelling evidence that life could exist elsewhere in the cosmos. While scanning the vastness of space, the telescope identified lights on a far-off exoplanet, glows that resemble the illumination of distant cities. This raises a tantalizing prospect that an alien metropolis might exist on Proxima Centauri b. The scientific community is abuzz with anticipation, as this could mark the kind of revelation they've long been hoping for, one that points to intelligent life possibly running civilizations beyond our wildest imagination. From a staggering distance of 4 light-years, NASA engineers are left in awe, wondering how long these lights have been shining, patiently awaiting our technology to catch up and finally detect them. Astronomer David Kipping from Columbia University described the planet as uniquely complex. Unlike most rocky planets that absorb sunlight and re-emit energy as infrared radiation, Proxima Centauri b behaves very differently due to its unusual interaction with its host star. This discovery underscores a critical role the James Webb Space Telescope plays in exploring cosmic mysteries. Its cutting-edge ability to detect infrared wavelengths was vital in observing Proxima Centauri b's unusual atmospheric behavior. This has prompted scientists to plan deeper investigations of the planet's atmosphere to assess whether it could truly support life. Thanks to its unmatched infrared sensitivity, the Webb Telescope can observe Proxima Centauri b even during its night phase. While many telescopes struggle to capture faint signals in the deep darkness of space, Webb excels at detecting even the subtlest flickers. This makes it the perfect tool to verify whether these so-called city lights on the planet's dark side are genuine. Importantly, the telescope can distinguish artificial light in space, provided it falls within a narrow frequency range, much more specific than the broad spectrum emitted by stars. Proxima Centauri b has a highly dynamic relationship with its star. It absorbs intense energy, experiencing cycles of blistering heat during the day and deep cold at night. These extreme temperature shifts are due to the planet's unique composition and the possibility that it lacks an atmosphere. Without atmospheric insulation, one side of the planet could be scorching hot while the other is freezing, offering scientists valuable clues about its physical makeup. The James Webb Space Telescope's ability to capture infrared thermal emissions enables astronomers to analyze these temperature differences and delve deeper into the planet's atmospheric conditions. As future observations unfold, Webb's contributions will be crucial. Interestingly, the telescope's orbital path around Earth aligns with Proxima Centauri b's own orbit, allowing for continuous and optimal observation of this mysterious world. Proxima Centauri b completes an orbit every 11.2 Earth days. If this exoplanet has an atmosphere, the next critical step is to analyze its chemical composition to assess whether it might support life. Scientists will look for signs of key molecules like oxygen, water vapor, and methane, indicators that biological processes could be present. This involves studying the starlight that passes through the planet's atmosphere, a sophisticated and intricate method. The James Webb Space Telescope JWST, though not primarily designed for atmospheric studies, is capable of analyzing components like water vapor, carbon dioxide, and methane with remarkable precision. However, it struggles to detect free oxygen, a vital clue in the search for life. Still, JWST can identify ozone, a related molecule that also signals a potential for a life-sustaining environment. As scientists continue parsing the data from JWST, the search for distant habitable worlds intensifies, bringing humanity closer to answering one of its greatest questions. Are we alone in the universe? That said, JWST is limited to observing a relatively small number of exoplanets near our solar system. To expand our understanding, astronomers will soon rely on ground-based observatories like the extremely large telescope YELT, set to begin operations in 2028. The YELT will enable more detailed examinations of distant exoplanetary atmospheres, offering clearer insights into their habitability. Looking ahead, researchers have bold plans for next-generation space telescopes. One key goal is to reduce the overwhelming glare of starlight, which makes observing faint exoplanets incredibly difficult. Future instruments will use techniques similar to shielding your eyes from bright sunlight, allowing them to detect and analyze the faint light reflected from exoplanets more effectively. To overcome this challenge, scientists are developing cutting-edge tools. One promising innovation is the coronagraph, a device installed within telescopes that blocks the central starlight, allowing the planet's weaker light to be seen. By manipulating light waves, coronagraphs drastically reduce the star's brightness and reveal the dim signals of orbiting worlds. Another groundbreaking concept is the star shade, a giant flower-shaped spacecraft that flies in formation with a space telescope, tens of thousands of kilometers apart. The star shade would block starlight before it ever reaches a telescope's lenses, allowing only the planet's light to be captured. This technique is particularly well-suited for studying planets in the habitable zone, regions around stars where liquid water and life might exist. However, these technologies demand extreme precision. For example, positioning a star shade must be accurate to within a fraction of a millimeter over vast distances. They must also be resilient, capable of operating efficiently, surviving the rigors of space, and functioning with minimal energy. Despite these technical hurdles, the potential payoff is enormous. Successfully observing and decoding exoplanet atmospheres may uncover biosignatures, chemical markers like oxygen, water vapor, or methane in specific ratios that hint at life. These clues could offer the first concrete evidence that life exists beyond Earth. Researchers are also working toward capturing direct images of distant planets with unprecedented clarity. Future telescopes will likely use adaptive optics that correct for distortions caused by Earth's atmosphere or the movement of the telescope itself. Combined with these advancements, we're entering an era where detailed exploration of alien worlds may soon become a reality. With the advancement of starlight blocking technologies, scientists are not only improving their ability to detect exoplanets, but are also moving closer to mapping their surfaces and analyzing their climates. The development of next-generation space telescopes marks a monumental leap forward in humanity's ongoing quest to answer one of its most profound questions. Are we alone in the universe? These technological breakthroughs are dramatically enhancing our ability to observe distant worlds, bringing us ever closer to discovering whether life exists beyond Earth, a revelation that could fundamentally transform our understanding of our place in the cosmos. The pace of progress in space exploration and the search for extraterrestrial life is unprecedented. As astronomers and researchers delve deeper into the mysteries of faraway exoplanets, the James Webb Space Telescope is ushering in a new era of cosmic discovery. Its data is fueling groundbreaking insights into the structure, composition, and potential habitability of these remote worlds. Each new finding brings us a step closer to answering the ultimate question: is there life beyond our planet? The recent discovery by Proxima Centauri b may represent a pivotal moment in our exploration of alien life. Proxima Centauri, the closest star to our solar system, has long been a subject of scientific intrigue. Until now, detecting definitive signs of life, such as artificial illumination or indicators of advanced civilizations, seemed like a far-off dream. The Webb Telescope's detection of such light renews hope that we may one day establish contact with intelligent life beyond Earth. This discovery not only fuels scientific inquiry, but also captivates the public imagination, inspiring new generations to look beyond our planetary boundaries. As the James Webb Telescope continues its mission, it is not only searching for artificial light, but also studying the atmospheres of exoplanets, analyzing their chemical compositions, and identifying conditions that might support life. Detecting biosignatures like methane or carbon dioxide in the right ratios is crucial to understanding whether these planets could sustain life. The Webb Telescope's unmatched ability to probe atmospheric components offers vital clues about the potential of distant worlds to host life as we know it. Perhaps the most fascinating part of this endeavor is that we are essentially observing the past. The light we capture from these exoplanets has traveled for years, sometimes decades or centuries, to reach us, allowing us to witness the universe as it once was. Each observation is a glimpse into cosmic history, a journey through time itself. As data from the James Webb Space Telescope continues to pour in, humanity finds itself on the threshold of a new era, one where questions once thought unanswerable, like the existence of alien civilizations, may soon be resolved.